Welcome to Ask and Learn.
All right, so here we're given two real valued functions and told that f is big O of g of x, and that n is a positive integer. We want to prove that f raised to any power, that is an integer power, is going to be big O of g raised also to an integer power. Okay, so by big O notation, we know then that the absolute value of f of x is less than or equal to some constant c times the absolute value of g of x, right? And this is going to occur when x is larger than some point. We are interested in the absolute value of f to the power of n, right? Which, can be rewritten just depending on preference as sort of the function itself raised to the power of n. So this notation change, same meaning. Okay, what this really means, though, is that we can put the absolute value sort of inside the bracket, right? So this is also going to be equal to the absolute value of f of x raised to the power of n. And that's just because of the way that the absolute values work, keeping everything positive. So we're writing it in this form just to make things a little bit clearer, right? And so then this is going to be less than or equal to, based on our big O notation, of c times the absolute value of g of x to the power of n. Okay, but this expression we'll work with. I'm going to work with it on a new page here. So we had that the absolute value of f to the power of n is less than or equal to c times the absolute value of g of x to the power of n, right? So this is equal to, and again, this is just like a notational change, is going to be c to the n times the absolute value of g to the n, but we can just rewrite that. So we'll get c of n to the absolute value of g to the n. And just sort of moving the absolute value brackets along. But so in this form, if we just let c1 equal c to the n, then what we've ended up with is the absolute value of f to the power of n is less than or equal to c1 times the absolute value of g to the power of n. And this is, of course, going to only occur when x is greater than some k. All right, and that will conclude the proof.